Welcome once again to the group exhibit, Hydrogen Fuel Cells and Batteries at Hanover Fair 2016. Please do come in. Drinks are on the house. Please do feel that you can join the discussion as well. Raise your hand at any time if you have any questions, and I'll come around with the microphone. My name is Christine. I'll be your moderator for this session, which is entitled Diagnostic Converter for Fuel Cells and Batteries with Real-Time Monitoring. Joining me on stage is the CEO of NOVUM Engineering, Mandy Schipke. Please join me in welcoming her on stage.
Hello. Okay. Hi.
Thank you for joining me.
Yeah, thank you very much.
So, can you start, please, by telling us a little bit about NOVUM Engineering?
Okay. Hello, everyone. I'm glad that so many people found the way over here. My name is Mandy Schipke. I'm CEO of the NOVUM Engineering. We're a young company, Dresden-based. We're developing small and smart power electronics for fuel cells and batteries with integrated real-time monitoring. The company isn't that old. It was founded 2014. And perhaps I should tell you something about the people behind. We have different backgrounds from science and commerce, equal times. Since we started the real operations in 2015, we are in black figures. I'm very glad about it. By the end of last year, we closed our first investment round with High-Tech Gründerfonds, and now we are working, developing our technology further and grow our team further.
So congratulations that you have sales, you're in the black, that's fantastic. So you're still developing products, but you have products already on the market.
Yeah, all right, we have.
How many products do you have on the market?
At the moment, just the one over there. It is a kind of double premiere for us because the device itself, it's a DC-DC converter. Hasn't been shown to the public before, so please take a look at the optical. We had a designer for it.
It's very beautiful. I like the packaging. It's
thank
nice.
you very much.
Everybody does a black box. Why not a white box?
Yeah, right. A white box with some strange green things on it, but it kind of tastes. Yeah, and what is new too is the software package that comes with it. Perhaps we can show the slide. Hello. Great. That's part of the software package. If you don't understand it right now, it doesn't matter. We'll come back to it later and you'll understand everything, I promise.
So you develop not only the hardware, the power electronics, but also the software that goes along with it.
Right, we do.
Excellent. So let's back up a little bit about the converters themselves. So we talk a lot about fuel cells and fuel cell systems.
Yep.
Where do the DC-DC converters fit in within the fuel cell system?
Okay. If you get power and energy from fuel cell systems, you ever need power electronics to use it. Even if you want to store it, you need DC-DC converters, or if you want to put it in a grid, you need AC-DC converters. No, DC-AC, sorry. So to use the energy, you ever need power electronics. And why shouldn't we make the power electronic a little bit more intelligent than it is at the moment?
Okay, so the power electronics translate the energy that you produce. You produce DC energy from your fuel cell, and you need to get it into whatever voltage and current and phase. So that's your box is an electronic translator.
Yeah, but that's nothing new. You use power electronics since hundreds of years. So that's not the new point of that. The new key components, we do have two ones actually. The first one is the power electronics itself. It works after a new principle. We do have a new topology, causing 400 times less ripple currents than it is usual at conventional power electronics. For those who don't know this, you have to imagine ripple current is a kind of disturbing current. And at fuel cell systems, it tends to increase the fail vulnerability of the systems. Batteries, the same. And at the end, these ripple currents are causing much shorter life cycles than it could be. So if we don't produce these currents, we are eliminating many problems right from the start. That's the first thing we do. And because we don't have these ripple currents, we can do much more software engineering than we could do when we have to filter it out.
So you're increasing the reliability of the fuel cells. So you're adding value for the lifetime of the system, but you're also adding value for the customer, the end user, but also for, say, utility, whoever's looking at the data. So how do you facilitate the looking at the data?
Looking at the data, okay. Whew, that's a large topic.
But you make it easy. You make it easier for the customer.
I try to make it easy. Huh? Please stop me if it isn't easy. Okay, we are running impedance analysis through the ongoing operation of the system. Until now, it wasn't possible. You have to switch the power electronics off if you wanted to see these curves. Huh? Without topology, you don't have to turn it off. The system runs and runs and runs. The power electronics work and work and work, and you get information. The question is, what do I do with all these informations? Nobody wants to look at these things, huh? And nobody wants to interpret these things. So we perhaps can interpret a little bit together. You can look over there. These are two curves from a fuel cell. The smaller one, the dark green one, is from a new fuel cell, and the light green one is an older fuel cell. So what the software does, it calculates from these curves how long will my fuel cell last. Huh? In best case, the device tells you in 4 months, 3 weeks, 2 days, 4 hours, you have to change the stack of Grandma Miller in her cellar. So you can plan it much more better than now, and you don't have to change it just per intuition, I have to say. What else can we see? We can see the relative humidity at PEM systems, or gas, don't know how to say, gas composition.
The composition of the gas.
Yeah, thank you. Great attention. Okay, what else can you see? We can see gas under supplies and something else. What is it exactly we can see over that? We don't know. It depends on what the customer wants. I can tell you what the customer wants. Perhaps you can tell me, or perhaps we can find out together. Huh? Don't know.
Okay, so this type of information you can find out earlier. So when you need to service. So it could be the warranty providers. It could be the actual providers of the fuel cells that might be interested in this information. So they have a real-time understanding of how their products are working in the field. The utilities that need the energy might be interested, or the curious consumer who has it in their home and wants to see how everything's working might want to understand. So information is power, and you're making information from power.
Yeah, right. You're very well prepared, I have to say.
So I'll be on your marketing team. Yeah.
Perhaps we'll talk afterwards.
Okay. Right. So how do you? But you can get this information remotely. So you have to get the information. Wonderful. So do you provide a screen for the customer as well in the package, or how does the consumer interface with the information?
It depends a bit on what the consumer wants. Huh? We can put a monitor on this thing so you can see it at the device directly. Problem is, when you build it in a system, you often don't see this box. You don't want to see this box. You perhaps want to see it on your monitor. It works. Huh? We do have an intuitively user interface, so you can see the main values over there, and we can make it easy for you. Huh? Nobody wants to interpret these curves, so we have some kind of easy system. Huh? Red, fuel cell in danger, yellow could be in danger, and green, everything's fine.
Yeah, even I can understand that. Excellent. So you do a standalone product. Do you also do custom solutions working with system integrators?
At the moment, we're at that testing time. Huh? We're just testing at SOFC systems at the moment, at PEM systems at the moment. End of this year, we're going to test at batteries, because the interesting thing is it works with batteries too. We can see with this impedance analysis the state of charge much more exactly than it now works. We don't have to count some strange electrons or something else. It works with it. And the degradation of batteries you can see also. So at the moment we're testing. Testing is the main issue. If somebody wants to test it with us, just put a hand over there.
So you're looking for partners to work on system integration?
I would love to find partners to test it.
Okay, so if there's anyone out there. So where are they currently installed so where you're testing internally, or there's any external projects as well?
There are external projects, but I don't want to talk in it in the moment.
Okay, so talk to her afterwards then about that if you're interested. Yeah, okay. I would like to open it up to questions at this time, if there are any from the audience. If not, you mentioned, so electrons are electrons. They work with fuel cells regardless of the fuel cells. They work with batteries. They also work with electrolyzers. Is that correct?
Yeah, but electrolyzers, we don't know much, because the technology is very new, and impedance analysis, while ongoing running of the system, is very, very new, and we are just at the moment trying to find out what else can we see with it.
Okay, so that's very interesting. That's the next generation plan.
Right.
Yeah. Do you see yourself going into any other fields beyond fuel cells, or?
That's a nice question. At the moment, we're a little bit limited by our basis range. It's 1.25 kilowatts. We can scale up until 5 kilowatts easily, no problem. By the end of the day, hopefully, we will be at 30 kilowatts. But I do have a little problem at the moment. It's very interesting for the automotive sector, but you all know with 8 people, it's kind of future music to think about the automotive sector. We are working on it, but it is kind of future music.
So when you say the automotive sector, you would put your power electronics directly into cars?
Yes, it's the thing we're discussing at the moment. The interesting thing is the impedance analysis doesn't interest them. Ripple free is fantastic.
Okay. Very interesting. So are there other products like this on the market already, or?
That's a different question. Some products can do this impedance analysis much better than we do. But you have to pay 15,000 euro at different companies to buy measurement technology to do this. And you ever have to switch off your power electronics. So it's indeed the first power electronics with integrated impedance analysis. I hate the word world premiere, but everybody throws it out here in that.
Okay, so when you're looking at data in real time, so does that change the efficiency of the conversion at all?
No. The conversion, because of this topology, we do have a very good conversion. We don't have problems with it, but the analysis hasn't an effect on it.
So how is it that nobody else does it then and you're able to do it so well? Just unique intellectual property, or? Intellectual property is a fact. The basis is the new topology. Indeed, nobody works with the topology we do. I'm wondering why, because it isn't that complicated, but nobody uses it until now. So now we do have a patent on it. Sad. Wonderful. Well, hopefully they'll come to you to figure it out, and you'll have customers in the near future.
I hope so.
Wonderful. And if customers do want to find you and you're open to partnerships, you're at booth B40, which is just over on the other side here. If there are no other questions from the audience, then I would like to thank Mandy so much for joining us today on this talk on power electronics. Thank you.
Thank you very much.
So please do stick around. Following this talk, right away, we will have a talk on the development of Norwegian hydrogen fuel cell activities and strategies. From the Norwegian Hydrogen Forum, we have the Secretary General, Christian Vek. Thank you very much.